Hey guys, what is a space elevator? It's not science fiction. I actually have heard that a lot of different people are working on this, different ideas. But a space elevator is kind of this, I don't want to say far-fetched, but really ambitious idea to build an elevator up to space. It's gonna be a lot of floors I know to go through, but no. But basically, it's like a different type of elevator that would allow the transportation of both people and items like satellites at a much cheaper rate to get to space in the first place. So what's the idea? So right now we're currently using rocket fuel, and it takes a tremendous amount of energy, as you can imagine, to take all this, basically all this mass on Earth and get it up to space. For example, the current cost, even with like SpaceX and like all these different companies that are trying to lower the cost, is at least $1,000 per pound. I'm gonna say that again, $1,000. Okay, if you even were on the light side and you weighed 100 pounds, it would take you $100,000 to get to get you in space. So there's got to be a cheaper way. And if there was, we would be able to do much more. We'd be able to get much more satellites up. Our cell phone plans would probably cost like half at least. It would be a lot cheaper that way. So what we're thinking of doing, the space elevator idea, is to get basically just a very strong rope out into space. Now, just kind of like when you take a child and like they're like swinging a bucket of water around them, you know how the bucket of water like stays out in front of them, and that's like centripetal force that's taking that bucket and keeping it out in front of them. That's kind of the idea with the space elevator. So you take a rope, you tie it down to Earth somewhere, probably where it's not stormy, and you get it up into the atmosphere, all the way up into the atmosphere, and at the end you attach a weight like the bucket. So the rope is the same rope going up to space, and then you have the bucket or some sort of station up there that's the counterweight. And that is just what swings it just basically kind of rotates. And the thing is that with the space elevator, you don't have to use rocket fuel. That's the most important step, because rocket fuel is really expensive. With space elevator, you can use different types of fuel sources, different types of energy sources, such as lasers. There's a lot of tests where they have like a reflector from the elevator, the reflector's reflecting down. And from base camp, you just shoot up a laser, and that laser kind of pushes the elevator up. And so an idea is to just push the elevator up, and using laser, I mean, that's direct energy to lift. And that's one of the most efficient ways you can basically make this elevator go up to space. So why is this really like important to you guys right now? Well, it's important because if you got it to work, you'd be able to get everything like cheaply up into space. Why hasn't this happened right now? The biggest impedance for this is basically we don't have a material strong enough for that rope. That rope is under so much tension that, if it snapped, I mean, the people at base up there are kind of, lost. So the whole point is that we have to figure out a material that's able to withstand both the forces on Earth, the forces in the stratosphere, and the forces in space. That's really hard. Plus, you got to build it. So that's another challenge as well. But the major challenge is the material. So right now we've been thinking carbon nanotubes because theoretically they can handle it. They're strong enough. But the problem is the manufacturing process. We just haven't figured out a way to manufacture carbon nanotubes cheaply and long enough. We can't get them. It's like more than, I think even like a centimeter is like a challenge. So trying to get it, kilometers is just ridiculous. Miles is out of the question. So we need to figure out a way to revise this situation. I mean, a couple of our ideas is that you do multiple ropes, because if you do multiple ropes, that decreases the tension. But even if you did 10, so it would be like 1/10 of the force. If you had 10 ropes, because the force is distributed evenly between the 10, it's just still wouldn't be enough. It's just the force, like, I mean, steel just wouldn't even be enough for that. That's how much tension there is, and you have to have a safety factor, which means it has to be more tension than you actually need just in case something goes wrong. So that's what the main challenge is. But hopefully people are able to develop some new materials and new manufacturing techniques, and we can get a space ride to space. Yeah. Thanks, guys.